Hi everybody. Today we're going to focus on just a couple of extra problems here on implicit differentiation. It's not going to be a long video, but I want you to see just a little further step in the process that I didn't go over in the previous video. So let's take a look here. Right into a few examples. I want to talk about this guy. Now, on the surface, it may look like it's an easy problem, but right here we have a product. So that means we're going to have to use a product rule to do the problem. So as you do that, remember this is your U and this is your V. And then we'll deal with this first and then we'll get into the rest of it. Okay, so we're going to use the product rule right here. So remember the product rule is U prime V plus V prime U. Well, U prime is 1 because the derivative of X is 1. Then times V, so that's 1 Y plus the derivative of y times x. So that's really x, and the derivative of y, remember, is dy dx. So you have to remember that as you do the product rule. U prime v plus v prime u. Okay? Plus, of course, the derivative of y again, which is dy dx equals 0. And as in yesterday, we have to now solve for dy dx. So the first step in doing that is subtracting y from both sides. And that gives me x dy dx dip 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 dip. Pardon me for the dips. All right, plus dy dx equals negative y. And then what I'm going to do is factor out the dy dx, of course. So it'd be x plus 1 dy dx equals negative y. Now you could also take the dy dx and put it in front, but I always have the habit of sticking dy dx in the back of things. So it doesn't matter if you put the dy dx here or over here as long as you follow the correct math. Now I'm just going to divide both sides by x plus 1, and I'm done with the problem. All right, there's my derivative. Now the key to this problem was, once again, right here. Okay, I'm going to keep this over here as a model and do a second example. I'm going to say x squared y cubed plus y squared equals 6. Okay, so it's still the similar problem, but it will have a different answer. Remember, we have the product of x and y here. So we have to use the product rule. This will be my u, this will be my v. So let's see here. U prime is 2x v y cubed plus the derivative of this times this. Well, I always tend to put x first, so that's why I'm writing it there. And so then the derivative of 3y cubed is 3y squared dy dx. Okay? And of course then we take the derivative of the rest of the problem. And that equals 0. Okay. Now once again, remember the dy dx comes from the chain rule. So really all this is an extension of using the chain rule. Okay. Well, now we need to move some things around. So I'm going to take this to the other side and simplify a little bit. So that would be 3x squared y dy dx plus 2y dy dx equals negative 2xy cubed. And now, of course, just like the problem here, I'm going to factor out the dy dx. And I get this. And that still equals negative 2xy cubed. And now I divide, and I get dy dx is equal to negative 2xy cubed over 3x squared y plus 2y. And that's the answer. Okay, you can see these problems are very similar. It was using the product rule to do the problem, so you just have to be careful as you go through. So let's look at one more, just to be on the safe side. All right, and see how it goes. Now this has three terms to it. This term, which is not product rule, but this term is product rule, so we'll have to pay attention there. And of course, not product rule and not product rule. So we just start from the beginning. This is 4x, nothing else, just 4x. Then we take the derivative of this, and I am going to say that this will be my u, and this will be my v, u, v. Okay, so the derivative here, u prime, the minus I'm going to take with the u as well, so that would be minus the derivative of negative 6x. Okay, so that's just 6, and then times v, so that's y squared. Okay, then the derivative of this times this, so that would be minus 6x times 2y dy dx. Yes, in these cases I always put v prime last because of the dy dx component. Then plus 4 dy dx, and that equals 0. Okay? So simplify a little bit again, and I'm going to take both of these terms. Notice both of these do not have a dy dx on them, so I'm going to take both of them and shift them over here by subtraction or addition, whichever cancels out. Okay, so I now have, and simplify, negative 12xy, that's 6 times 2, x times y, dy dx, plus 4 dy dx equals, what is that? 6y squared minus 4x. And then, of course, factor out the dy dx. And then divide. And you're done. Okay, now you have to be careful here because every now and then some other weird things come in, like trig functions and stuff, but you have to be careful. That's all there is to it. Let me show you one possibility with a trig function so you'll know, and this will be the last one we do today. X squared, well, let me keep it even a little more simple so you understand. All right, let's do the cosine of xy equals 16. Well, equals, sorry, not 16, that's not possible. Equals 1/2. Okay, I want to take the derivative. I want to find dy dx. So we have the chain rule over here. So we know the derivative of the outside of the cosine is negative sine xy. Okay. However, remember we have to multiply times the derivative of this. Well, this is a product. So we have a u and we have a v. So we just follow the pattern again. U prime v plus v prime u, etc. Okay, so you have to follow the product rule there, and that equals 0. Okay, well, and now we solve for dy dx. You say, wait a minute, how do you do that? Well, that's not actually that hard. Actually, I'm going to change one thing. I know some of you are taking notes and it's probably going to drive you crazy right now. I'm going to make this an x over here. Okay, it's actually going to make our lives a little bit easier. So that, an x, sorry, so that would be a 1. So now, of course, we have to solve for dy dx. So the first thing I want to do is divide both sides by the sign. And that gives me y plus x dy dx equals 1 over negative sine xy. Okay, well, of course, this is where it gets funky. I'm also going to now subtract the y. So that gives me x dy dx equals 1 over negative sine xy minus y. Well, the final thing to do is get rid of this x. And normally I know everybody would just divide by the x and be done. But that's going to create a messy fraction over here. So what I'm actually going to do is multiply both sides by 1 over x. And that'll make our lives just a little bit neater. And that gives me the final answer. Now I'm going to just distribute 1 over x to each term. So that gives me 1 over negative x sine of xy minus y over x. And that's my final answer. Now this is going to be one of the more difficult ones you may have to do. This one and the previous one. So you need to just be careful, take your time, and work through it. I know you guys can do these problems. You just have to be patient as you work them through. Okay? All right, we'll see you tomorrow. All right, it's not wanting to stop.